we just had the test, so there was quite a wide range. Some people did perfect or near perfect. And a few of you, given the bonus mark, would have gotten a bit better than perfect, but some people have a lot of room for improvement. Luckily, the first test is only 15%, including the written and multiple choice. If you didn't do as well as you had hoped, this is a reminder to please take advantage of the different resources on Blackboard. So one that you may have not noticed, I think I posted an announcement about it, but it wouldn't have been up the first day, is the lecture playlist. So that goes straight to a YouTube link, so you can re-watch the lectures if you want to review certain concepts you found challenging. As I said on the first day, this is the most important item to use, so you should be testing yourself on these key terms. In particular, if you didn't do as well on the first test, I would recommend doing that before test review day and then coming to test review day. So in this class, unlike 1100, no one came to test review day. As a result, there's no video for that. So if you didn't do as well, I encourage you to take advantage of that. The date and time is available in the syllabus. It should be 2:30 in the room across from the library on the Friday before the next test. And there's, of course, the crash course notes here. Won't cover everything, but if you want to get the core ideas, you can use that. And not many have used this. I encourage you to use course questions if there's any terms you're confused about. So I want to be available to help, but some of you will have to put in more work. I will mention, I once, during my undergraduate education, gave a blank final. Kind of a long story maybe for another time, but let's just say that didn't help my grade. I still managed to get into graduate school. Don't take one bad test as a sign that you're doomed. Take it as a sign that you should study harder. Any questions about the test? So today's chapter is on language and thinking. So a two-part chapter, first half on language, second half on thinking, reasoning, bias, and related topics. Back when I took this course, almost exactly 10 years ago, Douglas College was using a different psych textbook written by David Myers. At the end of one of the chapters, he gave the human species a report card. Kind of a funny thing to do. He graded us on various abilities. For reasoning and bias, I think he gave us a C+. Various other things we got a B. But for ability to learn and use language, he gave our species an A+. And we'll be seeing some of the reasons why. For starters, every person in this room, if English is your first language, can understand tens of thousands of words in English. I can make any of those sounds, tens of thousands of different sound combinations, and you will effortlessly understand what I'm saying. In fact, you're so good at it and so have practiced it so much, you can't help it. I encourage you all, try now to listen to the sounds I'm making with my face, but not understand the words. If English is your first language, and even if it's your second language, you have almost certainly failed at this task. So we are very good at learning language. As we'll see later in the language acquisition section, kids pick up on language very quickly. They're like sponges for language. During peak language acquisition, something like 10 words a day, depending on the estimate you look at, is how fast kids pick up on language. And I'm now going to show a video explaining one impressive feature of language, which is generativity. So as I already said, we understand by adulthood tens of thousands of words, and we can understand a potentially infinite number of sentences. Given the rules of grammar, there's a potentially infinite number of sentences. And to demonstrate this, I have a video from Steven Pinker, one of the most important psycholinguists. Okay, so that's generativity, one of the key terms. That's the idea that the rules of language enable us to understand a potentially infinite number of sentences. And this is not unique to one culture or a set of cultures. Anthropologists have never discovered a society that does not have a rich, complex language. So the next section goes through some of the basic building blocks that are common to the world's languages. First two are phonemes and morphemes. Phonemes are the smallest units of sound in a language. So different languages will have somewhat different sets. Some have more, some have less. English has around 44. So you may think, why is that more than the number of letters? And there are different reasons. So for example, TH, or SH for that matter, those would both be more phonemes, right? TH is not two sounds, it's one sound, right? Different vowels will have multiple phonemes associated with them. So for example, the letter A could be A, like I ate, or like apple. So when you add it all up, you get about 44 different sounds in English. So some will blur together different phonemes. So Japanese does not distinguish between the L sound and the R sound. So that'd be one fewer in that case. So that's phoneme, and if you want to remember that it means that, phone, ring, ring, sound, that's how I did it in undergrad, but you can use whatever you want. Morpheme, which helpfully starts with the letter M, a morpheme is the smallest unit of meaning in a language. Smallest unit of meaning. This is not the same as a word. So some words will be morphemes. So, the word the, that's one morpheme, which has one set of meaning. But it's not the same as a syllable, because the word apple also is just one morpheme, even though it's two syllables. Right? The ol doesn't add extra meaning. Apples has two morphemes. The letter S in some contexts is a morpheme by itself, because in this case, it's not a word, but it means plural if it's added to the end of a word, so it has meaning on its own. The word relearning would have three morphemes. So not a word, but it means, do it again. Learn, acquire knowledge, and ing means the action is going on now. So that would be three morphemes. Any questions about these two building blocks of language? There are two associated terms with each. So phonological rules are rules about how you combine phonemes into words. And morphological rules are rules about how morphemes combine to make words. Another category of rules that I'm going to spend more time on is syntactical rules, also called syntax. These are rules that a language has that govern how words can be combined to make phrases and sentences. So different languages will do it differently. To take a simple case, think about the rules for combining adjectives and nouns. So in English, the adjective goes first. If you want to refer to a red car, you say red car, so adjective first. In French, it's the opposite. You would say, l'auto rouge, right? The car red. So that's a difference in the syntactical rules. One case in which English is actually in the minority is English is a subject-verb-object language. So if you want to refer to a person doing a thing doing an action to a thing, you say it in that order. So you would say, Bob poked the bear. So the bear is the object, thing where something's being done to it, and you say Bob verbed the object. If you classify languages in this way, the most common way of doing things is subject, object, verb. So, Bob the bear poked, which would mean in English, Bob poked the bear. So all of that falls under the syntax umbrella. Any questions on that? Semantics has to do with the meanings of words and sentences. So what they refer to. So the semantics of the English word bear would be that it refers to a particular type of mammal. That's the semantics of that word. So syntax has to do with word order, semantics has to do with the meanings of the words. Another important term here is pragmatics. Sentences on their own, without background knowledge and without context, are ambiguous in themselves. Often, we employ context and things that we know about the social world in order to understand ambiguous sentences. If that sounds really abstract, I'll give a simple example that I am stealing from Steven Pinker. So let's say there's a man and a woman. And the woman says, I am leaving you. Aw. And the man says, who is he? So, let me just ask, what does the word he refer to in this conversation? No one knows? You all have very impaired. So the woman says, I am leaving you. The man says, who is he? Who's the he that he's asking about? Sorry? Why she's leaving him. The man's romantic rival, or as someone in my Monday class said, the guy she tells you not to worry about. Most of you, I hope, were able to figure that out. But there's nothing in the actual words about a romantic rival. If you manage to understand this, maybe it's too early for some of you to use pragmatics, but you were using pragmatics. You're using social knowledge you have, kind of background knowledge you have, and the context to understand the sentence. Okay, any questions about these terms? So the next section is on language development, which will build up towards one of the most important debates in psycholinguistics. By the way, psycholinguistics just means, linguistics means study of language. So psycholinguistics is the application of psychology to language. So I mentioned earlier that different languages have different phonemes. Some have more, some have less. Research indicates that babies start off able to distinguish all of the phonemes of the different languages. and they lose the ability to distinguish ones that they don't hear, spoken by people around them. Now, you may wonder how we know that. So here's the setup. We know that there are certain images that babies like to look at, that they will look at longer. And you train the babies that certain sounds cue that an image is coming. So whenever there's the ah sound, there's a pleasant picture, and then the babies look at it. And so you can use this to test whether babies can distinguish certain sounds. If you can train them to look when a certain sound is presented, that shows they can distinguish it. If you look at babies who are around 6 months old, both babies from Japan and the United States can distinguish the L and the R sound. By the time the babies are closer to a year, the Japanese babies have lost the ability to distinguish those sounds because they don't hear it spoken by people around them. And presumably you'd find the same thing if you compared subjects who speak English with subjects who hear English, I should say, with subjects who hear Punjabi, if you use the two J sounds. So it's a process of pruning. You lose the ability to distinguish sounds that you don't hear. After soaking the sounds in, babies start to babble. The first sounds that babies usually make are the ones that involve just pressing the lips together and apart. So ma and ba or pa are very easy to make. The book has an error here. It says that different sounds are first, but I looked it up to double check, and the book is indeed wrong on this point. It's a good reminder, don't take things on faith, either things that I say or that the book says. But the first sounds are typically the ma, ba, and pa sounds. Probably not a coincidence that these are the most common sounds for parents. So the fact that mother, mama is mother in English is not unique. That's the most common sound for mother cross-culturally. English is a bit weird in that father and dad are the common terms for father, but baba and related terms are the most common for father if you look at other languages. Probably not a coincidence that these are the first sounds that babies make. There is also hand gesturing that starts to emerge. If the kid is deaf, the parents will take advantage of this to try to teach sign language. Sometimes it's easier to teach babies simple words in sign language if they do it before they babble. So with one of my siblings, we tried to teach him a few basic words in sign language. He wasn't deaf or anything, we read it in a baby book, so we thought, hey, it might be fun. We tried to teach him that this meant more, but we didn't do it right. This wound up meaning more Cheerios. So, you know, if he's eating a carrot and he did this, we give him more of the carrot, and he'd be like, no. And he was only satisfied when Cheerios were given, so at least we tried. This will eventually grow to the kid will start to use actual words and engage in what the book calls telegraphic speech. So telegraphic speech is using 2 or so words at a time to communicate simple ideas. Me hungry, throw me ball, stuff like that. So not grammatical yet, but they're beginning to communicate. Very important thing starts to happen after that, which is the kids start to learn grammatical rules. And there's a specific pattern that emerges that gives us evidence that what they're doing is absorbing rules. And that's overgeneralization, sometimes called overregularization. Overgeneralization is applying a rule to a case where it doesn't apply. So you're over-applying So a case where this shows up is irregular verbs. This is a commonly studied case in psycholinguistics. This is a common mistake that kids make when learning their mother tongue. So in English, to use a common example, the rule for making a verb past tense is add ed. But English sucks, so there's a lot of irregular verbs where this doesn't apply. So the past tense of to eat is not eated, it's ate. The past tense of to swim is not swimmed, it's swam. What kids will do, though, is say things like, I eated or I swimmed. Now, they can't be doing that because they've heard other people say that. So that shows that what they're doing is internalizing rules, and in this case, applying them to cases where they don't apply. So that's the meaning and significance of overgeneralization. Steven Pinker will mention this in another video I'm going to show. As I mentioned at the beginning, the rate at which kids start to acquire vocabulary becomes very rapid, something like 10 words a day, depending on which estimate you look at. How do kids accomplish this? How do kids learn language at such an impressive rate? And here we get to one of the most significant debates in, actually really all of psychology, but certainly in psycholinguistics. And that's the debate between B.F. Skinner and Noam Chomsky. How many of you have heard either of those names? So good. So in 1100 you would have seen for sure Skinner, maybe Chomsky too. So can anyone tell me what school of thought was Skinner associated with? Does anyone remember? Yep. Behaviorism. So Skinner was the big behaviorist. Watson was the first one, but Skinner in the mid-20th century turned it into the dominant paradigm in especially American psychology. So we won't go into too much detail, but behaviorism involves three main commitments. The first one is only study behavior, hence behaviorism. So Skinner did not think that we should be theorizing about the nature of the mind, or having theories about what people believe or desire or things like that. Just so you can think of him as a very strict empiricist. Only study what you can directly observe. And in the case of human beings, what you can observe is their behavior, what they do. Take it, this marker's better. Number two, which is going to be relevant to the language debate, he thought that humans were basically blank slates. So if you've heard of the nature versus nurture debate, this would put him and the other behaviorists squarely on the nurture side. They did not think that genetic differences were important in determining how we turn out. They thought that we are purely a product of things in the environment. And number three, they thought that the way that the environment shapes us is through different types of conditioning. So in 1100, you learn about these types of conditioning in more detail. For our purposes, one type of conditioning that's important to know is operant conditioning, which is essentially reward and punishment. So to increase the frequency of behavior, you give the organism something it likes, or you stop hurting it. Both of those will count as rewards or reinforcements. To make a certain behavior decrease in frequency, you punish the organism in some way. So all of that falls under the heading of operant condition. Skinner then wrote a book called Verbal Behavior, in which he tried to apply the principles of behaviorism to language acquisition. And he argued that, look, language acquisition emerges from complex patterns of reward and punishment. I'm being a little crude, but roughly, the kid says the words right, the parents go, good job, Timmy, here's a cookie. They say the words wrong, very bad, Timmy, Mom and I are very disappointed in you. In other words, it's not built in from the beginning, it's purely the result of reward and punishment contingencies in the environment. So that's the behaviorist explanation of language acquisition. By contrast, Chomsky put forward a nativist explanation of language acquisition. So you can be a nativist about different things in psychology. What it means is you believe that a given psychological capacity is partly innate, partly fixed by the genes. So if you're a nativist about language acquisition, it means you think that part of it is built in at the beginning. Chomsky thought that there were aspects of language, different types of structures that languages all have, and he called this universal grammar. So he thought that all the world's languages had some structure in common, and that this is built in advance by the genes. Now, very crucially, he's not saying that any particular language is innate. So it's not that, people, of a given ethnic heritage are more able to learn the language associated with that ethnicity. It's just that there's something built into all human beings that we all share in common that makes language acquisition easier. It's part of our evolutionary heritage. So that's the disagreement. Now, before I get into different arguments for and against this, any questions about the two views? Yes? So native is a broad term. It just means you think a given psychological capacity is partly innate or partly built by the genes. And Chomsky is a nativist about language. So, is there any reason to take this seriously? So, one reason the book gives, so I should say, before I get into the reasons, as a matter of history, as far as the consensus of psychologists is concerned, Chomsky won the debate. So, Chomsky wrote a paper called A Review of Verbal Behavior in, 1959. And the date matters that it was around there, because that's around the time behaviorism started to fall out of favor. Within 10, 20 years, there were very few behaviorists, and now you'd be hard-pressed to find anyone who identifies as a behaviorist in psychology. They did discover real patterns, so people still study conditioning. That's perfectly real. But there are very few people who will accept all three of these commitments. And if you had to point to one thing that, as you learned in 1100, there were many things that led to the fall of behaviorism, but this was probably the most important. So now we don't say in science that consensus makes something right, but for whatever it's worth, Chomsky is kind of, or some version of it is more the standard that you'll find in the textbooks. So one reason to consider what Chomsky says is language ability is partly separable from general intelligence. So we'll see more about how we define general intelligence in the next chapter, but there are various measures of how good you are at learning, how much cognitive ability you have that are non-verbal, and you can score highly on those without having language ability. There's specific deficits you can have. One specific one is, and you don't have to know this for the test, but there's something called the FOXP2 gene that certain families have a mutation in, and it makes them unable to learn language at a normal level, but doesn't affect other cognitive abilities. Chimps have the old version. So that's another related interesting finding. Another finding that this is associated with a term that's good to know is there's a sensitive period for language acquisition. if you don't absorb a language before roughly puberty sets in, you will have a very hard time learning it later. So there are a couple of more than a couple, tragic cases where someone is exposed to little to no language during childhood, either because of abusive parents or kind of freak situations. Very tough to teach them anything interesting later on. Less extreme case, learning a second language. It's much, much easier to learn a second language when you're a kid than when you're older. If you grow up hearing it, your brain is kind of like a sponge ready to absorb it. But as you get older, it's harder to do. And it's worth reflecting on how strange that is. It's not like kids are smarter, right? If I try to teach a kid calculus, it's going to be much harder than teaching an adult. But language, they seem to be ready to absorb it. An argument that Chomsky made that was very influential is the poverty of the stimulus argument. Now, there are different objections I could give to this, but I won't get too deep into philosophy of science, but it's an important argument to know as far as the history of this debate. So, just to make things simple, let's make this the kid's brain, and specifically the kid's brain at the beginning. So this is what the kid is born with, what's built in by the genes. The stimulus in this argument refers to all the input that the kid receives from the environment. So all the words he or she hears, all the reward and punishment, praise and finger wagging that the kid gets, everything the kid is exposed to from the environment. And then the output is the language ability that the kid acquires by the time he or she is an adult. So the kid is born with a certain amount of stuff built in. He or she receives input from the environment, various words they hear, praise they get, etc. After 18 years, the kid has adult language ability. The Chomsky-Skinner debate essentially is, what's in here at the beginning? What's built in when the kid's born? And if you're Skinner, the answer is almost nothing. All that's built in is the ability to be conditioned by the environment, nothing else. So, I mentioned the name of this argument is the poverty of the stimulus. What this means is, so poverty means not enough, right? There's not enough stimulus here to produce adult language abilities just by conditioning. The kid is not exposed to enough reward and punishment and conditioning to produce adult language abilities without something more being built in at the beginning. That's the poverty of the stimulus argument. Any questions about the poverty of the stimulus argument? Okay. There are also some concrete real-world cases that have been used in support of Chomsky's theory. What I'm going to present now is sort of the Chomskyan interpretation of these events. You could interpret them differently, but they're good to know. One case that's sometimes pointed to is the transition from pidgin languages to Creole languages. So this is kind of a sad topic, but pidgin languages are not fully developed languages. They are sets of maybe a few hundred words, and they were used by slaves during the slave trade. So during the slave trade, they would often mix up slaves taken from different lands, so they couldn't communicate as effectively and revolt or something like that. But the slaves still had to communicate to kind of get through the day, so they would put together a pidgin, a few hundred words, maybe some taken from English, like the language of the slave masters, maybe some from their local tribal languages. And again, what emerges is not a fully developed language, it's just a makeshift communication system, just enough to get through the day. Pass me the shovel, please, or whatever. The question is, what do the kids speak? So the kids grow up hearing the pidgin. If it's just reward and punishment, the kids should learn the pidgin. But in fact, what emerges is a new language called a Creole, which is a fully developed language with syntax, grammatical rules, and a rich vocabulary. So the kids sort of fill in the gaps. Even with this limited input, as long as there's a community of kids, they will produce a fully developed language. And many Creoles still exist today. So the Chomskyan interpretation of that would be, look, linguistic structure is already built in. The kids are sort of, looking for linguistic structure, and they'll fill in the gaps if they need to. So that's how they would, Chomskyan would explain the emergence of Creole languages. Okay, there's one other case I'm going to talk about too, but I realized I forgot to show a video, so you can consider this a fun break. So, fun fact about Chomsky. So Chomsky was, at one point, the world's most cited living person. He's not anymore, someone else has beaten the record. But despite this, the reason for that is he wrote about many topics, including philosophy, psychology, politics. Even though he was a trained linguist, he wrote on many areas. But despite his notoriety, he devoted a few hours every day to answering every email that he got. He was famous for this. He would talk about it in interviews. He had a stroke recently, so I doubt he's still doing it. But a few years ago, I tested this a handful of times, and I always got replies that only Chomsky could have given. And as a kind of a funny aside, I'll show a video of him talking about the sorts of emails he gets. Okay, so that's just kind of a funny aside about Professor Chomsky. So there's the Pidgin Creole case. Another case that's relevant to the next section is something that happened in Nicaragua. So they made one school for deaf kids in Nicaragua. The deaf kids in question didn't know any other deaf kids until they were brought to this school. At the school, they were trying to teach them things that would help them interact with non-deaf people, so like lip reading and things like that. They weren't making all that much progress. What they discovered is, during the lunch hours, the kids, just through interacting with each other, had developed their own language. The language still exists. It's Nicaraguan Sign Language. So the language, as I say, still exists today. And what this shows is, even if Chomsky's right that language is in some sense innate, you can't develop one on your own. It has to emerge from a linguistic community. So one way of thinking about it is, there's an experiment that sadly we can't do because of research ethics. If we were to take a baby at birth and put it on an island by itself, let's say we left, milk bottles around and no predators, and it was able to grow up, that baby will not acquire a language. But if you dropped a bunch of babies on this island full of milk bottles and no predators, probably the kids would put together a language. So you need both the innate capacity, but also a linguistic community. Okay, any questions about the Chomsky-Skinner debate? Okay, another video, this is from Steven Pinker. Pinker worked at the same university as Chomsky and is in most respects an ally of Chomsky, so he argues that language is at least partly innate. So in this video we'll talk a bit about that and also about something we already mentioned, which is overgeneralization. Okay, so all of that is good to know and is basically the standard that you'll find in the intro psych textbooks. I will just note one recent development that has caused many Chomskyians to appear worried. If you look at recent interviews of people like Steven Pinker or Paul Bloom and other defenders of the Chomskyan perspective, a certain set of inventions has made them worried. I am referring, of course, to ChatGPT. Now, I am not an AI expert, but my understanding is the nodes in the deep learning networks start off essentially randomized, and they learn through, in part, a process literally called reinforcement learning. I knew someone who was a grad student in AI research, and she told me, yeah, they stole the term from Skinner. It's not the only part of the process, but ChatGPT has been referred to as a kind of Skinnerian machine. And as all of you know, speaks perfect English. Now, the pushback from the Chomskyans is, okay, fine, but it's exposed to way, way more data than a kid is, so they still appeal to the poverty of the stimulus argument, but who knows, in 20 years, Skinner might get a longer section of the textbook, because there are ongoing attempts to model how kids learn language based on these deep learning type language systems like ChatGPT. Don't have to worry about that for the test, but just flagging that as a possible point of future work in this area. Though, take what I just said with a grain of salt, because obviously not my area of expertise. One other contribution of Chomsky's is the distinction between surface structure and deep structure. So let's take written sentences first. In the case of a written sentence, the surface structure would be like the shapes of the letters on the page. You could, in theory, mimic the surface structure of a sentence without knowing anything about the meaning. So you could look at a sentence in Mandarin Chinese, replicate the shapes. Well, not me, because I'm bad at writing things carefully, but someone better than me could replicate the surface structure perfectly, but not know the meaning. If it's spoken language, the surface structure would be the sounds. So all that falls under surface structure. The deep structure is the meaning. So these would be structures presumably in the head, right? The understanding of what the sentences mean. These can come apart in interesting ways. For example, you can have two sentences that have different surface structures, but the same deep structure. So take the sentences, John loves Mary, and Mary is loved by John. Surface structures are obviously different, but they mean the same thing, right? So they have the same deep structure. You can also have cases where there's a single sentence, like a single surface structure, but multiple possible deep structures. So as an example, take the sentence, the police should stop drinking after midnight. This could mean the police are drinking after midnight and they have to stop doing that. Or there's some law against drinking after midnight and the police have to stop people from breaking that law. So one surface structure, but two possible deep structures. A lot of humor and intentional and unintentional results from this distinction. So as an example, I have a list of real headlines that I got from the internet where there's one surface structure, but two possible meanings, two possible deep structures. One that's sensible and one that's not so sensible. So stolen painting found by tree. Include your children when baking cookies. Blind woman gets new kidney from father she hasn't seen in years. And probably the worst one, panda mating fails, veterinarian takes over. So, probably should have worded that differently. So, those should reinforce this distinction. Any questions about this? I see some of you trying not to laugh. It's okay, you can laugh, it's good for you. Okay, that's the end of the language acquisition section. There's then a brief section on language and the brain. Not too much detail, you learn more about the brain in 1100, but there's a few key areas that you should know about. So the first thing you should know is that for most people, especially if you're right-handed, language is primarily localized to the left hemisphere. Language ability primarily depends on regions in the left hemisphere. The reason you can connect it to being right-handed because as you learn in 1100, everything is contralateral with the brain. It's always the opposite side of the brain that controls a part of the body. So if you're right-handed, it's the left hemisphere that controls the right side of the body. Language, of course, very important for humans, so it makes sense that it's localized to the dominant hemisphere. Left-handed people mess it up. Some of them it's evenly divided, some it's localized to the right. They kind of mess it up, but for most people it's localized to the left hemisphere. There's two regions that are particularly important, and if these regions are damaged, you get very specific types of impairment in language. These two are both in the left hemisphere, at least for most people, and they are Broca's area and Wernicke's area. These are both named after scientists who studied brain damage case studies, so Paul Broca and Carl Wernicke. That's how you know you made it, if you got a part of the brain named after you. So Broca's area is in the left frontal cortex, and it is involved in language production. So making sentences, so speaking, writing, etc. This makes some sense because the near Broca's area is the motor cortex, which sends commands to the mouth and hands. So before actually initiating signals to go down the spine to the lips, tongue, and hands to communicate, Broca's area is involved in the planning of those sentences, if you want to speak loosely. So that's Broca's area, language production. So someone with Broca's aphasia, and aphasia just means a deficit in language resulting from brain damage. So this would not include things like dyslexia that emerge developmentally. This has to emerge after brain damage. So hit to the head, tumor, surgery, whatever. That's what an aphasia is. So Broca's aphasia, someone with Broca's aphasia, if you tell them, go to that room, go to the top left drawer, open it and get the bottle of pills at the back, they can do it, showing that they understand the sentences. So the comprehension is fine, they just can't produce sentences. They can still talk, they can still make noises, but not words or sentences. Wernicke's area is in the left temporal lobe, and it's important for language comprehension. So understanding language. They can still talk with words, but they can't string the words together into meaningful sentences. And if you try to communicate with them, they can't they can hear the sounds, but they can't make sense of them. So I mentioned that language is lateralized to the left hemisphere. So if a given psychological capacity is lateralized, that means it's reliant more on one of the hemispheres. There's a sex difference. Now, as with all sex differences, these are only on average. It doesn't mean every single male is one way and every single female is the other way. But there's a difference that, on average, males exhibit more lateralization. And this includes language. So what that means is, for males, language is more exclusively the domain of the left hemisphere. Whereas for females, on average, language involves the two hemispheres more equally compared to males. Any questions on the basic neuroscience of language? The next section's on bilingualism, so speaking two languages. And this is an area where psychology actually, or psychologists, change their mind with better studies. And the debate here is about, is bilingualism a cognitive advantage or disadvantage? And a priori, you could imagine this going either way. You could imagine it being the case that learning a second language as you grow up gives your brain kind of a workout. That's, handling, multitasking, handling different streams of information, and therefore produces a cognitive advantage. And you could imagine it being a disadvantage. You could imagine it being kind of taxing and taking away from other abilities. The early studies tended to favor the second hypothesis. If you just zoom out and compare kids who grow up with two languages and kids who grow up with one language, it was associated with deficits in other cognitive tests, like IQ tests, standardized tests, etc. Later studies pointed out that there was a confounding variable, which was socioeconomic status. The bilingual kids, on average, were more poor, and poverty is associated with difficulty in those kinds of tests. When you match kids by socioeconomic status, so you compare rich kids who speak one language, rich kids who speak two, and so on, you find the opposite, that bilingualism is an advantage, that it's associated with better performance on cognitive tests. There are various other advantages that it's associated with, and to say more about this, I have a video from the linguist John McWhorter. I mentioned Creole languages earlier. John McWhorter is one of the world's experts on Creole languages, and he's going to talk about some of the advantages of bilingualism. Now, even though I showed that video, I suppose I'm a bit of a hypocrite, because I only speak 1 1/4 languages, but in Spanish, I would say I'm at the level of a 4-year-old. I took it in high school, but probably forgot most of it. And all of French I repressed. Okay. Next section. This is a section that's a lot of fun, but also the subject of some controversy, is on different attempts to teach non-human animals language. So most of the work here done with our primate relatives. We thought we had the best chance there. There were early attempts to teach chimpanzees, gorillas, etc., how to speak, and it was discovered they simply don't have the right kind of vocal control to learn how to speak different words. There was more success with teaching them sign language. So, lots of video. How many of you have seen these videos of apes that can do a bit of sign language? So a few of you have seen it. So one of the most famous ones was Coco. Coco was a gorilla. Various chimps and bonobos were also taught some amount of sign language. There's debate about the estimates of how many words they can speak, but I think the consensus is they've never gotten past the level of something like a 4-year-old in terms of amount of vocabulary. So one thing that there's no evidence of them being able to do is rich grammatical rules. So something like, you know, the pen is in the cupboard owned by the friend of Bob's teacher. You know, no problem, you all understood what I said. No chance that any of these animals could get that. Typically it's just a few words at a time. So for example, I have here a passage from Steven Pinker's book. This is of some of the most common things that a particular animal would say. And there's kind of a funny backstory to this one. So Noam Chomsky, remember that he thinks that language is an innate capacity of humans. So he was very critical of this research. He thought, look, you guys are all having fun, that's fine, but this is of no use because it's innate in humans. You're just teaching these animals basically how to ask for food and stuff like that. So that's Noam Chomsky. So the animal researchers decided to have some fun at his expense, and they named one of their apes Nim Chimpsky. So it's kind of the academic version of a prank. So one of the most famous animals named after Noam Chomsky. But in Pinker's book, these are the most common things that Nim Chimpsky would say. Nim eat, drink eat me gum, tickle me, nim play, me banana, you give. So one of my students, upon hearing that, said, modern day Shakespeare, and yes. So having said that though, the videos are still very cute, so I have some video of, it's basically required that in an intro psych class you see these videos. This is some video of Coco. And one thing that I think is significant is Coco had a pet cat, and she it was a female gorilla. She made a sign for the cat, and the trainer communicated to Coco that the cat had died because the cat got hit by a car. And Coco had a very visible reaction to this news, so seeming to show that, yeah, the meaning is able to get across. Okay, so nothing too fancy in the the animal section. One other thing I'll point out, so there's an ongoing debate about how advanced their abilities got. One thing I do agree with Chomsky on is whatever is discovered here, it probably will have no relevance to how humans learned language. And the analogy he uses is kind of a funny one. So bees communicate via dancing. They have like a dance that signals information about where flowers are, etc. If you were to get animals from another species, let's say human graduate students, and you taught them how to do the bee dance, well, that's kind of fun, but you're not going to thereby learn how bees acquire their communication system. Okay, we have one more thing about language before moving on to thinking. We'll take a slightly shorter break because I was a bit tight for time on Monday. So let's take 10 here. So come back at 11 and we'll finish the language section. All right, everyone. Let's wrap up the language section. So there's just one more section about language. And to start us off, we're going to do a little activity. So very simple. I want you to draw something, and just do it quickly. You will not have to show it to the class. I'm not expecting brilliant artistic ability. I want you to draw a stick figure boy pushing a stick figure girl. Stick figure boy pushing a stick figure girl. Okay, show of hands, anyone need more time to get at least the basic shape? Okay, you can just go there. So look at the direction of the pushing. show of hands, who has it going right to left? Who has it going left to right? Okay, so I've done this dozens of times. That's what happens every time. The vast majority of people have it left to right. Why is that? Anyone want to venture a guess?
Because we read left to right.
Because we read left to right. And the reason we know that, if someone is a native Hebrew or Arabic speaker, where the words are right to left, they will draw it in the opposite way. This is a cute little example that illustrates the next idea, which is the linguistic relativity hypothesis. So this was put forward by the linguists Benjamin Whorf and I think Edward Sapir. So it's sometimes called the Sapir-Whorf hypothesis. And in its extreme form, which arguably they held to, this hypothesis says that the language you speak shapes or determines how you think. So again, in the extreme form, if you believe this, you think that people who speak different languages will think in different ways. So some other examples, and these are examples that are well supported. One example that's commonly pointed to is how we divide up the color spectrum. So different languages have different numbers of words for colors. Believe it or not, many languages, and all languages if you go far enough back, start off with just 2 words for color, light and dark. The next one to emerge is always red. And after that, it's a bit, maybe green or yellow. Blue is typically last of the major color words. But some languages go even further. So for example, in Russian, there is no word that you can translate as blue. There are 2 words, guluboy and sini, and this is how they would divide. And you can experimentally show that if you're given a decision task where you're given 2 shades and you have to decide are they the same or not, yes or no, Russian speakers are faster if the words are on the opposite side of this dividing line. They're quicker at categorizing them. There are other ways that language can affect how you think. So in particular, with regard to thinking about mathematics, language can matter. In the old days, the Europeans used Roman numerals, and if you haven't ever done this, try going home and doing arithmetic with Roman numerals. Very, very unpleasant. When they took Arabic numerals and used those instead, it makes doing mathematics easier. Another remaining outstanding deficit in many European languages is the words we use for numbers. So lots of goofy exceptions. So for example, words like 12, 13, these can be an impediment when kids are learning mathematics. In Mandarin Chinese, it's a simple set of rules that makes it easier to learn. So they don't say 11 or 12, it's just 10, 1, 10, 2, and so on throughout the numbers. So the consensus today, according to the book, is that this hypothesis is maybe half right. You can show various experimental effects related to different words, different languages that people speak. But in the extreme form, some of the early proponents said things like, some people don't even think in the past tense. That people can think in fundamentally different ways. That's probably too far, but to illustrate some of the ways in which this hypothesis has been supported, I have another TED Talk. Okay, so that is the end of the color half of the chapter. Any last questions? Okay, so the next half is on thinking. First term is concepts. concepts and categorization. So in the way that psychologists think about concepts, concepts are categories we have in our head. They're mental representations of the world. They're sort of buckets that we can put things into. So I could refer to concepts like cats, dogs, squares, round objects, whatever, and you can all think of different objects that would fall in those categories. A long debate, both in philosophy and psychology, is how do we do this? So we may have a concept, Y, cats, square, whatever, different concepts, and then there are particular things like X. And we are able to decide whether X belongs to category Y. How do we do this? What are the criteria we use for deciding whether X belongs to category Y? There's an old idea, which is that we do this by appealing to necessary conditions. This is the idea that we have a set of criteria in our head, or conditions in our head, that X must meet in order to be in category Y. So necessary means like needed. So you have to meet this condition in order to be a member of category Y. So we have like strict definitions in our heads that, okay, if an object has these, meets these criteria, then it is indeed a member of that category. Nice idea, makes intuitive sense. It's just not how we work. For most terms in ordinary language, it is not possible to give a list of necessary conditions. Here's a dead simple case. Take the word game. Okay? Everyone here knows what a game is and can use the concept effortlessly. As a little bit of homework that I won't mark you on, because you'd all get it wrong, try to go home and write a definition of the term game in terms of necessary conditions. And what you want the definition to have is you want the definition to include all games and exclude all non-games. Right? That would be ideal. And when you try, you'll find that it's very difficult. So a first pass is often, well, a competitive activity between two or more people with a set of rules. And then you think, wait, no, but there's solitaire and that's just one person. Okay, that doesn't work, so you try to make it so it wouldn't include all games. Okay, you try to make it broader, and you think, well, any fun activity, but then it will include things that are not games. There are activities that romantic partners do with one another that we would not call games, right? So no matter how, if you either make it too narrow or too broad. So it does not seem to be possible, at least for most terms in ordinary speech, to define it them in terms of necessary conditions. So if that's not right, how do we do it? And in cognitive psychology, there are two leading theories: prototype theory and exemplar theory. Now, I'll start with what these two theories have in common. What these theories have in common is, first of all, they reject the idea of sufficient, necessary and sufficient conditions. And they think of concepts as clusters. Clusters of things that can be more or less similar. There are some things in the middle of the concept, or of the category, that have a lot of the features associated with that concept. Think, for example, of games. Something like soccer is going to be in the middle. It's a very typical example of a game. It has multiple people, fun, rules, etc. Something like solitaire might be more on the outside. Yeah, it is a game, but it lacks some of the features that most games The example that the book uses is the concept bird. So things like robins and blue jays and crows, they're going to be close to the middle. They have a lot of the features that most birds have. Fly, feathers, lay eggs, etc. Something like a penguin or an ostrich, they're birds, we all know they're birds, but they're kind of weird, right? Penguins don't fly, etc. So they're maybe more on the outside. Both these theories accept this. So what's the difference? I'll do exemplar first because it's easier. When we're in this situation of deciding whether X belongs to category Y, we compare X to actual members of the category Y. So if there's a new animal we're looking at and we're trying to decide whether it's a bird, we'll think of typical examples, hence exemplar, of that category. So we'll think of robins, blue jays, and crows, and think about how similar this new thing is to things like robins, blue jays, and crows. So that's exemplar theory. We compare new things to actual examples of that concept. The book has a picture using dogs as an example to try to illustrate these two. Ignore that picture, it's misleading. According to prototype theory, we don't compare new things to actual examples of the concept, we compare them to a prototype. A prototype is not an actual example of the concept. It's a kind of abstraction. So we kind of think of an idealized bird, a bird that would meet all the core features that birds usually have. Like the most birdy bird you could think of. Not actual birds like crows, robins, etc. Does that distinction make sense? Any questions about prototype versus exemplar theory? So again, we have to talk about some brain damage cases. So there are particular parts of the brain that seem to be very important for categorization. A lot of them are in the temporal lobe. You don't have to worry about that. And damage to specific areas can lead to what the book calls category-specific deficits. This is to say that you can have challenges with categorizing specific kinds of things, and it can be localized to one category. So probably the most famous example, there's a certain part of the temporal lobe, for whatever it's worth, it's called the fusiform face area, that if you have it damaged, you will have difficulty recognizing and categorizing faces. So these people can see clearly, their vision is perfectly detailed and crisp. So if my mother was to walk in the room, I would turn and go, yes, that is a middle-aged woman, blue eyes, clear teeth, blonde hair, but I won't be able to make the connection, that's my mother's face. So that would be one example of a category-specific deficit. The book goes through examples of people who have that kind of deficit for animals, for tools, etc. Okay, any questions on the section about categorization? Okay. The next section starts off with something called rational choice theory. This idea is very important in economics. So economics, what economists do is they produce mathematically sophisticated models that purport to model how humans make economic decisions. It's much easier to construct these models if you assume that people are rational, that they will do what's in their self-interest. even though it's a convenient assumption for mathematical modeling, basically the entire rest of the chapter is devoted to showing that this is at least often false. It's often not true that humans are rational and do what's in their self-interest. There are all sorts of biases and errors in reasoning that we commonly engage in. There's an old line about economists that relates to the idea that they often rely on assumptions. Okay, let's assume this and see what follows. The line is there's two people stranded on an island, and one of them is an economist. They have cans of beans, but no other tools or supplies. And the man says to the economist, how are we going to open these cans? And the economist says, assume we have a can opener. I said, well, we don't. The idea being, economists often assume that we are rational, but lots of evidence that we are not. A related pair of terms that you should know is algorithms and heuristics. These are two different procedures for solving problems. Algorithms are slow, step-by-step procedures that are guaranteed to give you the right answer. So, slow, step-by-step strategies that are guaranteed to give you the right answer. So, in school, you would have learned algorithms for things like long division, which probably most of us have forgotten, but there is a procedure for doing long division, and if you follow the steps, you will get the right answer. Heuristics are mental shortcuts. So these are quick, efficient ways of thinking that work better than chance. They're better than a coin flip, but they are error-prone. They're not perfect like algorithms are. The brain is expensive and evolution is cheap. Therefore, we often rely on heuristics. If there are mental shortcuts, we often take advantage of them. So they're not all bad. It's useful to be able to have heuristics, but it's good to know the ways in which they can go wrong. So there are two heuristics that you have to know. The first one is the availability heuristic. Here's how this one works. You have to make a judgment about probability, so how likely something is. And to make the judgment, you use how quickly something comes to mind, or how available it is to your mind. If something comes to mind very quickly, you infer that it's more likely. So, simple example, after my father saw the movie Jaws, which is like a shark movie, my dad wouldn't go swimming. So he's there at the beach, there's the ocean, and he asks himself, how likely am I to get attacked by a shark? Boom, very vivid example comes readily to mind, so you conclude, it must be somewhat likely. As I'm sure many of you know, it is in fact vanishingly unlikely. There are around 5 shark fatalities a year, compared to around 40 jellyfish fatalities a year. So very, very unlikely to die from a shark attack, but if you have a very vivid example in your head, you infer that it's more likely. Another example, after the 9/11 attacks, which of course involved planes, there was a significant increase in car fatalities because people started driving long distances to go to their vacations because they asked themselves, how likely am I to die in a plane crash? Boom, very vivid example of one. Actually funny, there was just one yesterday or today. And so you conclude, it's very likely. In fact, you were much more likely to die in a car accident, but relying on the availability heuristic led to this mistake, and hence increase in car fatalities. So that's the availability heuristic. The next one is the representativeness heuristic. So here's a question. Suppose we randomly sample someone from the United States, pick someone's name out of a hat. And the guy we get is Bob. So Bob is randomly sampled from the US. He is shy. He wears glasses. And he likes books. Okay, you can picture Bob. Here's a question. Is it more likely that Bob is a farmer or a librarian? Show of hands, who thinks it's farmer? Who thinks librarian? Right. So now it's a psychology class. Some of you didn't raise your hand. Maybe you suspect I'm trying to trick you, which I am. So that is wrong. Now, I fell for it too when I first took cognitive psych. The reason it's wrong is the first one. Bob is randomly sampled from the United States. There are far more farmers than there are librarians in the United States. Some percentage of them will be shy and like books. And that number will be way more than the number of shy, book-loving librarians. This is an example of relying on the representativeness heuristic, which for intro psych purposes basically means relying on stereotypes. There's a more technical definition, but that's good enough for your purposes. So Bob kind of fits our image of a librarian. So we think, yeah, more likely he's a librarian. In this case, it leads to us ignoring base rates. How common are librarians in the population? And because they're much more rare than farmers, in fact, it's less likely that he's a librarian. But in this case, the heuristic leads to us ignoring that. Any questions about these two heuristics? Okay, another random person, not Bob, but Linda. So here's a description of Linda. Linda is 31 years old, single, outspoken, and very smart. At university, she majored in philosophy and was deeply concerned with issues of discrimination and social justice. Okay, so there's Linda. You can form a picture of Linda. Is it more likely that Linda is a bank teller or that she is a bank teller and a feminist? So, show of hands, who thinks it is more likely that she is a bank teller? Who thinks it is more likely that she is a bank teller and a feminist? So again, more of you are not raising your hand because, again, I am trying to trick you. So most people say the second one. In fact, if you pause and think about it, it has to be number one. Because if she's a bank teller, if she's a bank teller and a feminist, she's also a bank teller. The probability of the first one has to be higher. The fact that we fall for this is an example of the conjunction fallacy. Conjunction means combining two things together. So and produces a conjunction. We sometimes mistakenly think that if we add extra properties to an event, that makes it more likely. But in fact, by definition, it makes it less likely. Because as I say, if she's a bank teller and a feminist, by definition, she's also a bank teller. So the probability of the first one has to be higher. Any questions on that? Okay, I'll run through some more terms. The next section this is not like the sexiest part of psychology, just going through different biases, but all of these are good to know for the test. So there's a family of biases that fall under the heading of framing effects. And here, framing is exactly what it sounds like. So when you frame a problem differently, you can make people respond differently. So here's a simple example. Suppose I have a group of cancer patients and I randomly assign them to two conditions. In the first one, I tell them, if you get this surgery, there is a 95% chance you will survive. I tell the other group, if you get this surgery, there is a 5% chance you will die on the operating table. Now, as it turns out, none of you will be surprised, people in the second condition are less likely to sign up for the surgery, even though I've given the same information to both groups. That's a simple case of a framing effect, where wording a question differently produces different responses. Again, think back to the rational choice theory that economics relies on. Strictly speaking, that's irrational. Right? It shouldn't matter how a question is phrased. If you're strictly rational, you should make the same choice either way. Another one, and this one is really hard to give up on, is the sunk cost fallacy. I find that some students resist even accepting that this is a fallacy, but it's very easy to fall for. I'll give an example before giving the definition. So suppose that there's an NBA team, so a basketball team, and they pay a lot of money for Joe. Joe had great statistics, seemed very promising, so they spend a ton of money on Joe, but then on court, he actually sucks. Right? He's not doing so well this time around. But the coach keeps putting Joe in the field to justify his decision to spend more money on him. So sunk cost here refers to, investments that you've already made. They're sunk. You can't get them back, but we still make decisions to try to justify those past decisions. If you're being strictly economically rational, you shouldn't do that. There's a saying in economics that bygones are bygones, meaning if you've already spent the money, nothing you can do about it. Don't use that when making future decisions. Okay, next term, like framing, it's what it sounds like. Optimism bias. People are more likely to think that they are particularly immune from bad things happening. So if you ask people, how likely are you to get colon cancer or what have you, most people say they are below average in their likelihood of getting cancer, which can't be true. It can't be true that most people are less likely than average, but so therefore by definition it's a bias. Okay, the next term that you need to know is expected utility. This helps set up the next bias. So if you wanted to make a robot that would make the most money in life, you would program it in accordance with expected utility. So when it's making a decision about which bet to take or which investment to make, it would take two things into account. The probability of an event and the utility or payoff of an event. So expected utility is the probability of an event multiplied by the payoff or the utility. So that equals expected utility. And when making a decision, the robot, if it was, again, perfectly rational, it would pay attention to this. This is what would guide its decisions. Here's a dead simple case. Suppose that I offer you the following bet. I'll flip a coin, and if it's heads, I'll give you $1,000. So the probability of the event, in this case $1,000, is 0.5. The payoff, if you get heads, is $1,000. So the expected utility is $500. So does expected utility make sense? So there are different ways that we deviate from this. One particular way in which we deviate from this is the certainty effect. What that means is, if this number is 1, if the probability of a payoff is 100%, we give it like bonus marks, more than we should if we were being robotically rational. So what does that mean? Let's say I offered you a choice. You can do 2 different bets. The first one, you have an 80% chance of winning $4,000. Okay, so whatever, random number generator, some other thing that gives you an 80% chance. If it lands on this, I'll give you the money. So if we're using expected utility, the expected utility is $3,200, $3,200. So that's one bet. The other bet is 100% chance that you get $3,000. So I say, just come up at the end of class, I'll give you $3,000. No coin flip. So probability is 1. The payoff or utility is 3,000. So hopefully you can all do this in your head. 1 times 3,000 is just 3,000. So the robot would pick the first one. Show of hands, how many people want to pick the first one? Show of hands, who wants the second one? Right, so this is the certainty effect, right? If the probability is 1, we give it more weight than we, strictly speaking, should, at least if we were, robots built by an economist. Any questions about this? There's really interesting work on these kinds of gambling and bet-making games in connection with a part of the brain called the ventromedial prefrontal cortex. So the frontal cortex in general is, to a first approximation, associated with things like rationality, slow, careful thinking, the more kind of distinctly human types of thinking. Self-control, etc. Whereas the limbic system, so parts of the brain like the amygdala that are deeper, are more associated with emotion and instinct. The VMPFC is a kind of hub for activity from the limbic system to make its way to the frontal cortex. neuroses. So it's close. It's kind of closer to the limbic system, and it receives a lot of signals from the limbic system. So, and then other parts of the frontal cortex will then maybe suppress those signals or choose to use them in decision making. So one way to think about the VMPFC is it's a hub for attaching value to different courses of action. Part of the reason we know this, if you look at cases of brain damage to the VMPFC, and you give them sort of gambling tasks where some strategies are more advantageous and others are less advantageous, people with damage to this part of the brain are less able to learn from that experience. Most people, when they play those games, can come to recognize that some strategies are better without consciously knowing why. They just sort of feel, ooh, when I do that, it doesn't work out, so I better stop doing that. They are able to anticipate, ooh, if I do that strategy, I'm going to lose money based on what I've experienced so far, so I should stop doing that. People with damage to this part of the brain are less able to do that. Antonio Damasio writes a lot about this in one of his books, where he argues that both reason and emotion are important for making good decisions. Part of what it means to be a rational agent, at least as a human being, is to sort of feel that, oh, that's a bad way to go, I better not do that. And therefore you're motivated to avoid the bad decision. Okay, a couple more boring terms, and then we'll have a somewhat fun activity. Another term, means-ends analysis. This is a fancy term for something that you all have engaged in since you were very little. So here, an end, in this sense, is a goal. So some goal that you have, that you want to achieve. A means is a way to get that goal, or a step you have to take in the pursuit of the goal. So you have to be at the movies at 6 for a date. That's the end. One mean would be I have to get on the bus by 5 p.m. or whatever. Nothing too fancy. It's just a way of referring to that kind of thinking. Another kind of thinking is analogical problem solving. So this is thinking by analogy. So this is where there are two problems that are similar or analogous. You know the solution to one of them, and you use that to inform how to solve the other one. So here's an example that the book gives. The target problem, the one that they want them to solve, is the radiation treatment problem. So the issue is when there's a tumor, in order to hit it with enough radiation to kill the tumor, you kill everything on top of the tumor. So how do you do it? And the solution that they're supposed to arrive at is you hit it from multiple angles. So the lines of radiation converge, killing the tumor without killing all of the tissue on top of the tumor. So that's the solution. People find this very challenging. But if you give them the solution to an analogous problem first, it helps them solve it. So a similar problem is, if you want to invade this castle, if you put enough troops on one bridge to defeat the army inside, you'll collapse the bridge. So the solution is you put troops on multiple bridges, not enough to collapse any of the specific bridges. If you give people that solution first and then the radiation problem, they are more likely to solve it, showing that they're relying on analogical problem solving. Okay, the next term we're going to talk about, it's a bit more fun, is creativity. This has proved harder to study than many of the other types of thinking that we've looked at. But there's a rough consensus on at least two requirements for thinking to be creative. So here's where the activity comes in. This is a real test that psychologists use. On your paper or computer, I want you to write down different uses for a brick. So you all know what a brick is. Write down as many things as you can think of that you could do with a brick. Okay, how many people have at least 5? Okay, we'll stop there. So I'm curious, anyone want to volunteer an answer? Who thinks they have a really creative answer? It's too early, no one's confident enough. So for whatever it's worth, here's how psychologists would be inclined to characterize different answers as creative. The first criterion is the answer has to be rare. So if you can imagine giving this question to a sample of 1,000 people. So for example, almost everyone at some point thinks of hitting someone with it. How many of you had, you could hit someone with it? Right, so if everyone gives it, it's not creative, right? Almost by definition. As a kind of funny example, sometimes when you talk with certain members of your family, you're in kind of a giggly mood. So I had a call with my brother, we were hysterical over the phone, and I went into class to teach on this. I asked for examples and people volunteered, and one guy said with this really bro-ish voice, "Oh, you could make a pet, like a pet rock?" And that just shattered all thoughts of reality. I broke down laughing in front of the whole class, and eventually I said, okay, we'll just take a 1-minute break. Just sat down, had my hands. So that's rare. I had never heard that. Did anyone say that, by the way? Also, okay, there you go. So somewhat rare, not crazy rare. The other feature that it has to have is appropriateness. Meaning it has to be a good answer. So you can imagine someone writing something like, a brick would make a really good t-shirt. That's going to be rare. Not many people are going to say that, but it's not a good answer, and therefore it wouldn't be creative. Maybe a sign of mental illness or something. Okay. So yeah, originality or rareness and appropriateness. Okay, so as we encounter various problems in our lives and use these different thinking strategies, it can actually decrease creativity. Your brain kind of becomes more rigid. It becomes used to using various solutions that have worked in the past, and therefore it becomes less flexible. There's actually, as I understand it, an analogous problem with AI models, that as they get used to solving problems, they can become rigid. You don't have to worry about this for the test, but some AI models use something called dual process architecture. Many people argue that the human mind has the same structure, that there's one system that is quick and efficient, and that's the one that's built up by experience. So you're used to solving problems in a particular way, and you just go with that. But there's also a backup system that's more flexible and able to change, that kicks in if there's a novel problem. So this is another example of AI researchers stealing something from psychology. So this was popularized in psychology by people like Daniel Kahneman, but AI researchers have found it useful for solving certain kinds of problems. One particular example of thinking that's too rigid that emerges from experience is functional fixedness. And we'll watch a video showing functional fixedness in action. So in that example, functional fixedness is what made it difficult to solve that problem. Functional fixedness is being too focused on or too fixated on what the function of an object normally is. So objects have a function or a use. So the function of a paint can is holding paint. And if you're too used to thinking about paint cans being used for that, too rigid, you are less likely to think, or at least slower to think, that they could be used for something else, in this case, as a pendulum. So that's functional fixedness. Does that concept make sense? The next section requires us to make a very important distinction. The distinction between truth and logical validity. Again, it's unfortunate that we didn't think of a different term. But, so this distinction is very important if you'll take a critical thinking class or a symbolic logic class. Have any of you taken critical thinking here at Douglas? So they'll hammer this home a lot if you take that class. I'll keep it brief. So when we have an argument in philosophy and reasoning, it's set up like this. There are premises and a conclusion. If the argument is good, the premises are supposed to support the conclusion. Meaning, if the premises are true, the conclusion also is true. So, standard case, many of you probably heard this example, all men are mortal. Whatever, use someone modern. Chuck Schumer is mortal, is a man. Conclusion, Chuck Schumer is mortal. Now, if the premises are true, the conclusion has to be true. If someone says, well, I believe that all men are mortal, and I believe Chuck Schumer is a man, but I don't think Chuck Schumer is mortal, they're being irrational. Because the premises, if true, guarantee that the conclusion is true. That is logical validity. Do the premises entail the truth of the conclusion? But you can have an argument that's logically valid, but has false premises. So just take a silly example, all cats have pink hair. Tom Cruise is a cat. Conclusion, Tom Cruise has pink hair. So, in the sense of validity that we're talking about, this is a perfectly valid argument. In the sense that if the premises are true, the conclusion has to be true. So it has, therefore, logical validity. What it doesn't have is true premises. Both the premises are false. So I could give other examples to illustrate, but to keep it simple, belief bias, which is one of the key terms, means that if you have a belief about the conclusion, you are more likely to make a mistake about the validity of the argument. So often people, if they believe the conclusion, they'll say the argument is logically valid, even if it's not. If they don't believe the conclusion, they'll say that it's logically invalid. So like, this is a silly case, but many of you would find it harder to accept that the argument is logically valid because you don't believe the conclusion. The book gives some other examples that are a bit less clear and therefore require more thought. And the common variable is, do people have beliefs about the conclusion? If they do, it makes it less likely that they will be correct about whether the argument has logical validity or not. So some students struggle with this. Any questions about belief bias? Yep.
That was why we did the double blind, right?
No, so that's internal validity. Well, at least related to internal validity. So this is a different type of validity. It's actually from philosophy, not psychology. Like I said, psychologists and philosophers should have gotten together and agreed to use like 5 different words, but oh well. Okay, next we'll do a little activity, and there is a point to this that I want to draw from it. We're all going to engage in some logical reasoning. Suppose there's 3 people: Paul, Susan, and Bob. The arrow here means looking at. So Paul is looking at Susan, and Susan is looking at Bob. And it doesn't carry forward. So Paul is not looking at Bob. Paul is married. Bob is unmarried. I'm going to write down a statement about this situation that's either true or false. Someone married is looking at someone unmarried. This is either knowably true, given the information I've given you, knowably false, or unknowable. So you can't know whether it's true based on the information I've given you. So think about what you think it is. So the statement, someone married is looking at someone unmarried. Who thinks it's knowably true? Who thinks it's knowably false? Who thinks it's unknowable? So we're going to do some group reasoning. I'll give you one bit of help. It is knowable. It's either true or false, and you can know based on the information I gave. Get into groups and discuss. See if you can figure out whether it's true or false.
Susan's married. Susan is married.
What do you think?
And if she's unmarried, then Paul is married. Yes. So Susan is married, and she is married, and looking at Bob, who is married. If she's not married, then Paul is looking at her. We have to know. So, yeah, it's true. Okay, in either situation. Okay, yeah.
It's gotten quiet. So now that you've had a chance to discuss, show of hands who thinks it's true. Who thinks it's false? Good, so we made progress. So we got to at least a majority of people who raised their hand said that it's true. It is true. I heard Purple Hoodies say loudly what the right answer is. Do you want to explain what you said?
Yeah, if Susan is married, then she is married looking at Bob, who is unmarried.
Yep.
And if she's unmarried, then Paul, who is married, is looking at her.
Exactly. So what you have to realize is Susan is either married or unmarried. And if she's married, she's looking at Bob, and then this is true. If she's unmarried, Paul's looking at her, and then it's true. So it is true. What this example is supposed to show, and has been used to show, is that group reasoning is often better than individual reasoning. Often in discussion, you can converge on a right answer. So, and again, it's kind of a fun little puzzle if you want to try it out on your family members. Okay, we're on the last page and a half, so including one more video I have to show, so hopefully we can finish it all before the end of class. The first term in the next section is the illusory truth effect. This refers to something that we've known for a long time. When a statement is more familiar, you've heard it more times, you are more likely to believe that it's true. It's not often that I quote Nazis, but Goebbels, the head of Nazi propaganda, once said, if you tell a lie and keep repeating it, eventually people will come to believe it. In this rare case, Goebbels is right. Hearing something over and over again increases the probability that you will accept it as true. You may not remember exactly where you heard it or when you heard it, but the statement is more readily available, and therefore it increases the likelihood that you'll believe it. An important bias that we've already talked about is confirmation bias. This section talks about a number of related biases. So confirmation bias being a tendency to think in ways that confirm what you already believe. So you seek evidence that confirms what you believe and interpret evidence in a way that confirms what you believe. The way that this plays itself out is when you read studies that go in favor of your belief and against your belief, you'll be more critical of the studies that go against it, against what you already believe. You read them more carefully, trying to find problems, whereas the confirming studies, you basically take at face value. And to talk more about this, now she doesn't use the term confirmation bias, but she has a term for it, scout mindset, or a soldier mindset, which is good. This is based on a book she later wrote. So this is Julia Galef, who wrote a very good book called Scout Mindset. And she concludes with some recommendations for how to avoid things like confirmation bias. So this is a helpful talk. Oh, actually, it's 11 minutes. We don't, okay. If you want, you can Google Julia Galef Scout Mindset. It's a great talk, but we'll run out of time if I show that. So I'll just finish with the other terms. But for whatever it's worth, the distinction she draws is between soldier mindset, where your goal is to defend the ideas that you have, and scout mindset, where your goal is to be more impartial and just get a look at the landscape as impartially as possible. The reason I like the talk is she concludes with some studies showing that susceptibility to these kinds of biases are not strongly correlated, if correlated at all, with things like IQ. It's not a matter of cognitive ability, it's a matter of motivation. Are you motivated to just defend the views you already have, or are you motivated to be more impartial? In fact, in some studies, people with higher cognitive ability show more confirmation bias because they're better at shooting down arguments that go against what they want to believe. So it's not just a matter of ability. As a kind of funny note,
Hi, sorry, Dr. Simpson, to interrupt.
Yeah.
I'm Daniela. I think we emailed back and forth.
Or are you the honor student?
Yes, I am.
Yeah,
I
so-
can wait a few more minutes.
Yeah, wait a
so-
few more minutes. Yeah.
sure,
So
sure.
she's going to talk about some opportunities for extra credit. So yeah, you'll have 5 minutes left at the end. Yeah.
Is it
You
okay?
each have a seat. Yeah, no worries. As a funny note about that video, if you look in the comments, you'll find people saying things like, "Oh, conservatives really need to hear this," or "Oh, liberals really need to hear this." And one person, bless their heart, says, "I think you guys are missing the point of the video." Okay, last set of terms have to do with overconfidence. So this is one kind of bias that's easy to fall for, especially for you all as you are in your first year. There's something called the Dunning-Kruger effect. So the x-axis is competence, or an increase in knowledge, and the y-axis is confidence. So what happens when you learn a bit about something is you move up towards Mount Stupid. So this is thinking, yeah, I got this. Some of you at the end of this course might think, I am an expert in psychology. I can diagnose my family members and everything. As you progress, you move towards the Valley of Despair. So you sort of realize how much you don't know, and your confidence goes down. Becoming an expert is moving up the final slope, where you start to get a deeper sense of what's going on, and therefore your confidence is more warranted. So how do we counteract overconfidence? One related term is the illusion of explanatory depth. This is another key term. It's easy to trick yourself into thinking you understand something better than you do. If you ask people, how well do you understand how zippers work or how toilets work, they'll report, oh yeah, it's simple, I understand. The way to break this is to say, okay, explain how zippers or toilets work. It doesn't take very long for people to hear their own voice and realize, I have no idea how these work. And so I'll conclude this chapter with a little bit of advice. If you're arguing with someone, it's better to ask questions than to give counter arguments. It's easy for people to try and find an error in a counter argument. But if you ask people, how do you know that? What do you mean by that? Explain more. People will hear themselves not make sense, and this is a more effective way of reducing their confidence and getting them to be more open-minded. So that's all I have to say. So there's enough time so she's one of the honor students, so she's going to talk a bit about opportunities for extra credit. So give her your attention, and once she's done, you will.